All right. So in the last session, in the last two sessions, what we have seen is the history of different subatomic particles. Ved, can you please remove that? Yes, that's much better. Yes. Uh, okay. So in the past, what we have seen is basically the three subatomic particles which we discuss along, right? J.J. Thomson was the one who discovered electrons, and then later on he gave the his atomic model also, right? Structure of an atom was proposed by J.J. Thomson. Meanwhile, Goldstein, he discovered about protons, right? Cathode ray and canal ray. That two are very clear now. Yes, everyone.
Yes, sir.
Yes, very good. Cathode ray experiment was done by J.J. Thomson, which you have studied in your previous standards, right? Your previous grades, you have studied about that, right? Then canal rays, that was one of the question in the textbook also. You have to work it out. You have to find out how the experiment was set up, and what were the observation, right? That you have to find out and make a note of it, right? And then later on, different scientists, they were conducting some experiments, and then they found that J.J. Thomson's model structure of an atom was inadequate, or rather with lots of follies, है ना? So Rutherford came in, and Rutherford gave another structure of an atom, right? That he predicted that protons are at the center in the nucleus, and the electrons are circling around it, right? That's what he proposed, that the electrons are, so here we have got, right, this is J.J. Thomson, right? Then came Rutherford, who said that nucleus is the one with proton charges, right? Positively charged particles called protons. They were in the nucleus of an atom, and the electrons are revolving around it. But later on, it was found, sir, my MCB has some problems, so sir, I have to join with Zoom with Sony. Uh, okay, you want the link? Hold on a second, right? Participants. But then I'll have to share it with you on WhatsApp, which is I'm not very comfortable with.
WhatsApp web.
Yeah. Okay. I hope you're not watching my screen right now, right? You cannot see what I'm doing on my other screen, correct?
Yes, sir.
It's better. You know what? It's taking too much of a time. Okay. How about, okay. Uh, who was the class monitor last year amongst you?
Push.
Sorry?
Push Prasapati.
Push, is he in the classroom right now? Push.
Yes.
Push. Okay. Push, I'm going to make you a co-host. Okay. I'm going to make you a co-host, right?
Yes, sir.
And now you can add all the participants. How about that? I need a little cooperation from you here, that you take care of that part, right?
Okay, sir.
Thank you, Kush. Thank you very much. Okay. Now, who had a problem with you can get in touch with Kush and get it sorted out, right? He will be able to join in now. Right. So let's get back to our own structures. Right. So J.J. Thomson model we have got here. Right. And then came in Rutherford. Right. And both of these had their own limitations. Right. They both had their limitation. Especially Rutherford's atomic model. What was the limitation of this model? It could not explain the charged particle moving around a nucleus. That phenomena, right? The problem is that this electron will generate energy because it's in constant motion, and because of that constant generation of energy, it will lose its own energy, and sooner or later it will start spiraling around the nucleus atom, ultimately getting ending up with the protons, right? Which obviously will result in right, positive plus proton plus electron will become neutral, and that will lead to the destruction of the atom itself, correct? But as we know that most of the atoms, they are quite stable. So this theory, this particular phenomena could not be explained because of by Rutherford. Okay, so again this model failed to help or the answer some of the questions raised by scientific community. So later on came another person, and meanwhile this discoveries, there was another gentleman, another scientist named Chadwick, right? This, he found out about the neutrons, that there are some more subatomic particles, and these subatomic particles, they do not have any charge on them. Okay, they do not have any charge on them, as a result of which it will be very similar to the mass of these are very similar to proton only, but they don't have charges and they are also part of nucleus. Okay, and then later on came Niels Bohr, right? Niels Bohr. Okay, this is another one big name, and you'll come across the scientist name again and again if you choose science in 11th 12th, and later on in whether you go for engineering, whether you go for pure sciences, this scientist will come up again and again across you, right? uh, he has done lots of different discoveries and inventions he made, but one of the best was obviously the atomic structure that he proposed. Okay, what he said that yes, the he definitely accepted that protons and neutrons are at the center. Yes, so that he borrowed directly from Rutherford. Okay, but what he proposed, second one, was that the electrons, they move in circular path across the nucleus. Again, same as Rutherford. Okay, but then he proposed one more thing, that these electrons, right? These electrons, they move in this parts dedicated to specific energy levels. Okay, this is very important part. At specific energy level, they will be moving in specific paths. When they have higher energy, right? This electron will jump to this one. How do you get higher energy? Obviously, someone else is supplying that energy, then only that will happen, right? Then only it can occur. So if you are bombarding the atom with electric energy, then that extra energy will excite these electrons, and they will move to the higher levels. And at higher levels, in this higher level, or rather I put EH. Okay, at this higher level, these electrons are excited, and when you are excited, you tend to do more things, which leads to loss of energy. So these higher energy electrons, they will be converted to, right? I'm just giving you very simple examples, right? When they give up this energy in terms of radiations, right? In terms of the radiation, they lose that energy, and then they fall back to their original level. Okay, clear on this one? So basically they are jumping up down, that's what they are doing basically, right? When supplied energy. right? So that's what happens with Niels Bohr's model of an atom. So he was able to explain a lot of phenomena, lot of atomic behaviors because of this theory, right? Clear on this one, everyone?
Yes, sir.
Okay. Yes, very good. Wait, Suni, are you in? Are you in the class?
Yes, sir.
Okay, very good, very good. Now, so we have got three different atomic models, right? J.J. Thomson, Rutherford, and Niels Bohr. Okay. Now Niels Bohr, like I said, he was able to explain a lot many behaviors of an atom because of this particular atomic structure model. Okay, but it was not able to cover all of them. That was the surprising part. There were still some questions which he was not able to answer them using this particular model of an atom, right? And later on, which is not, this is something which is not part of your study right now, right? Yes, the limitations are, right, and limitations are clearly stated in the textbook itself, right? So I'm going to ask you to read it out in a minute, right? Now, later on, right, different scientists came up and they proposed another model. They have come up with a lot many different versions, and after that, over the years, like I told you last in the last session, I told you to read about CERN, CERN, right? And they have found so many different subatomic particles, right? Last time I checked, I had read about 22 different types of subatomic particles, right? And these will be proven, I mean, they will be observed very soon. Like one of them was Higgs boson, which has already been observed, right? Practically proven that yes, it does exist. It's not theoretical concept, right? So how many of you did research work on that? Tell me, how many of you worked it out? How many of you search for what is CERN? CERN. Anyone? Is there anyone who read about it? Yes. Is there anyone? Arshil, did you read about CERN and other stuff that I had asked you to?
No, sir.
You haven't. Okay. May I know the reason?
Sir, I couldn't find it.
Sorry.
I couldn't find it.
You couldn't find it. Well, that's surprising. With a search for why human height does not increase more than 6 feet. Okay, Rishwa, we'll get back to that question definitely. Yes, the world's largest and highest energy particle collider and the largest machine in the world. That is correct, Ved. Yes, that is correct. That CERN is definitely one of the largest machine, and it spans across a couple of countries. If I'm not wrong, there are 6 countries below which the CERN has been established. Okay, there are basically 6 countries, right? If I'm not wrong, it's been quite a while that I read it. Okay? And they are generating. They are called uh, uh, hadron colliders, right? And these colliders, what they do basically is they spin subatomic particles at a very high speed, and which results into formation of, or rather separation of some of the atomic particles from the basic structure, and which can be later on observed for scientific studies. Higgs boson particle, right, or rather which is also called God's particle, right? That is also something which they did, and there are many people who oppose it, considering that humans should not play God. If it is called God's particle, then let it be with God, right? Which is not a scientific approach, honestly, right? So clear on this one, everyone? Okay, Nisarg, are you with me?
Yes.
Nisarg, I didn't see you. Can you please put your video on?
Okay, sir.
Yes, yes, sir. Thank you. Can you please put your video on?
Wait a minute, sir.
Sure. I'm waiting. Purva, Anand, Sahaj Tiwari. These three students I didn't see you earlier on. So can you please put your videos on? Nisarg, Purva, and Sahaj, who left the class. Nisarg, Nisarg is there. What is taking you so long, my dear? Okay, there you are. Right. Purva and Sahaj, can you please put your video on? That will be much better. Okay, so we have got, right. Thank God. See, this is what happens. I assume Purva was a girl's name. I'm sorry, because I had someone Purva as my classmate. So is it Purva or Purva? Let's be very clear. Yes, Purva?
Sir, it's Purva.
Purva. Okay, right. Like Gujarati word. That's better. It creates confusion a lot many times. Thank you for clearing that. Yes, very good. Okay. So as you can see from the textbook, right, Niels Bohr's atoms, right, in order to overcome the objects raised against the model, Niels Bohr, right, only certain spatial orbits known as discrete orbitals of electrons are allowed inside the atom, right? While resolving in the discrete orbits, the electrons do not radiate energy while they are inside this particular orbit. Okay, and that is why he gave them numbers, or rather alphabets: k, l, m, n. K is equal k for k shell, n is equal to 1, l, n is equal to 2, m, n is equal to 3, and n is equal to 4. So as we have discussed earlier on, that different atoms have different number of protons and equal number of electrons present in it. Okay, so what happens is, right, he decided that in one particular shell, say for example n is equal to 1, then it will have only a fixed number of electrons present. It cannot accommodate more than that number of electrons. If there are more electrons in an atom, say for example, if an atom has 8 electrons, it means obviously it has 8 protons. So those, out of those 8 electrons, first 2 will be in this one only. First 2 will be in uh, will be occupied in this one. Okay, then the further ones here, and he gave specific instructions, specific models, specific structures way, and specific number of electrons that can be given into this particular shell. Okay, we will study that very soon. Okay, right. Okay, so right, this is what he provided, right, are represented by the letters or the numbers. N is equal to 1, 2, 3, 4, right, and right. So any questions about this?
No, sir.
No, you sure?
No, sir. Yes, sir.
Yes.
Right, so I want you to find out that what were the limitations of Niels Bohr. So then what is 2n square? 2n square, where, Ved, speak up beta.
Sir, in this Neil Bohr's atomic model.
Okay, 2n. Yes, we will come to that. Right, we will come to that. That how many electrons can be occupied in it, and the number of electrons, or it. Everything will come on later on. Right, but for now, we have got three different. For now, as part of your study, we have got three different atomic models. Right. One is obviously J.J. Thomson, second the Rutherford atom, and the third one being the Niels Bohr's atomic model. Okay, I want you to note it down and do a comparative study of the three models. Okay, on one page, take one A4 size paper, right? Make 3 columns and write down a comparative study of these three atomic model. Okay, how will you do it? Obviously, first the structure of model proposed by these three scientists, right? In a figure format. Okay, then their proposals, their advantages or their conclusions, and later on their drawbacks. Right? Very simple. It will be on one page and it will help you immensely later on. Okay, clear on this one, everyone? Maitra, meet. Are you with
Yes,
us?
sir.
Sir, can you repeat the assignment?
Sure, will do. You have to do a comparative analysis of three atomic models. Clear?
Yes, sir.
Right? Now, in your textbook, Bohr's model, right? It is not showing any of the limitations. But I want you to find it out that what were the limitations of Bohr's model and was it the perfect one or not? That is an extra part. Okay, this will help you in 11th standard when the same chapter, basically this entire chapter is repeated in 11th science chemistry. Okay, and you will realize that in 11th there is one more atomic model and we will study about that when the time comes up. Okay, all clear? Yes.
Yes, sir.
Very good. Very good. So these are the four questions that you need to write down also. Basis of functions model as an atom, explain how the atom is neutral as a whole. Very simple question. Basis of Rutherford's model of atom, which subject particles present the nucleus of an atom. Again, it's a simple question, short answer type question. Now, sketch of Bohr's model of an atom with three shells, that is KLM, right? What do you think would be the observation if the alpha particle scattering is carried out using a foil of a metal other than gold? If it was any other metal other than gold. Now, here, this is very important part, metal other than gold. We are assuming here we are going to assume that the other metal that whichever metal we choose for experimentation will be as malleable as gold or at least very close to it, right? So malleability won't be an issue, right? Clear? This question is little bit tricky. Most of the time students answer that the other metal won't work or whatever, but I want you to make sure that okay, the thickness won't be an issue. Think about the other aspects. Okay, and don't go directly for ready reckoner study materials. Think about it a little bit. Okay, right, everyone clear on this one?
Yes.
Okay, that's very good. First thing, and obviously for thinking you will have to give proper logic that what could have happened if gold, instead of gold we are using any other atom, any other metal, then what will happen and why it would happen. I want you to cultivate this logic, this habit of asking the question why, right? Everything else is workable. This answer, giving answer to this particular question why, that's what makes the difference. Clear, everyone? Purva,
Yes, sir.
are you with me?
Yes, sir.
Good. That's better. That's better. So later on, neutrons were found, and you can answer the questions based on this. Name the three subatomic particles. Obviously, proton, electron, neutron, and helium atom has an atomic mass of 4 units and 2 protons in its nucleus. How many neutrons does it have? Obviously, same number of protons. Now remember, protons, number of protons equals number of electrons. They both have the same amount of charge but opposite polarity. Protons have positive charges, electrons have negative charges, right? And since they are both equal in number of the charge, an atom is always, any atom in its natural state is always neutral, right? Because number of protons equal number of electrons. All the charges have been cancelled out against each other. Clear? Yes.
Yes, sir.
Very good. Very good. And number of protons, right, does not equal neutron all the time. It may be different, it may be more, it may be less. It can be compared with, and it has to be studied on individual basis. Okay, this is very important part. However, the mass of proton equals mass of neutron, right? We discussed earlier that in atom its mass is entirely because of protons only, right? As suggested by Thomson and Rutherford, that protons are the ones carrying the mass. Okay, so they were saying that Rutherford said that protons are in the nucleus. How many neutrons helium has? Two, right? Two protons are there, and it has atomic mass of 4 unit. So basically two more neutrons. Okay, but like I said, it is not necessary that all the time number of protons equals number of neutrons. Mass of proton equals mass of neutrons, but number does not equal to each other. Okay, clear on this one? This is very important part. Many students make a mistake
Yes,
here.
sir.
Many students make a mistake here. Say for example, hydrogen. There are three forms of hydrogen, naturally occurring hydrogen. One is obviously hydrogen, where there is only one proton and one electron, which is in abundance. Okay. The second type is deuterium, right? Deuterium, okay, which has got one proton, one neutron, and obviously one electron, right? So its atomic mass will be 2 units. The normal one, the current, the abundant one is having only 1 unit. Okay, U is the mass of atom. Okay, and then there is third one, which is called as tritium, right? Or tritium. Sometimes it is spoken as tritium also, but tritium, we will stick to tritium, which has got 2 neutrons. Okay, so this is what makes the study of chemistry very interesting, that because this changes, the properties also change. Okay, the properties also change. Okay, physical and chemical as well. We will discuss about them later on in the next session. We will discuss why how the electrons are distributed in shells as per the Bohr's model, which is widely accepted, barring few questions, and that's what we are going to work. That is your assignment. Okay, and we will study also that the physical and chemical properties of an atom, how do they depend on number of protons, electrons, and neutrons. We will study that in the next session, that is on next Monday. Okay, clear on this one, everyone? Now, Rishwa, you said that you had read about why humans height have not increased more than 6 feet. Can you please elaborate?
Sir, it was like when these monkeys and evolved to humans, the monkeys have a hunchback. So slowly they start to straighten up their body, and
Okay.
slowly they increase their height. But
Mhm.
due to some genes and this transformation from one kind to another kind, the
One
height
species
could
to
not
another species. That is
species
the
to another species. The height couldn't increase more than the 6 feet.
very good. Very good. Now, this is the genetical reason behind it. Okay. Now, I want you all, again, right? Okay, and this is an open forum for all. I want you to study why an average human's height cannot be average, right? I'm not talking about special cases. There are special cases, right? American basketball players, they are all usually they are more than 6 feet, right? So, and then there is Shaquille O'Neal, who is almost 7. There are different players in cricket. Also, there has been players like who are almost 7 feet, right? So, what are the physical limitations, right? What are the physical limitations associated with increase in height? Like if an average human height is more than 7 feet, then what kind of problems in terms of physical science, in terms of physics, would he be facing? That is another extra question that you need to work on. Clear, everyone?
Yes, sir.
Yes, sir.
Yes, please read on this, right? These are the questions which will put you on a different league than others. This definitely won't help you in scoring the marks, right? That is guaranteed. Okay, those who are only aiming for scoring good marks, well, it has got its own perks, but then you won't actually start liking the science. The science lies in reading and thinking beyond the textbook, right? So go beyond the textbooks and try to search for this type of questions, generate your own questions and work on them to find the answers, right? That is very important for everyone. Okay, right, Chintan?
Yes, sir.
Good, that's very good. Okay, then well, I'll be sharing a few questions with you very soon, within this week only, and that those questions and their answers you will have to note down in your textbook. Okay, I'll discuss with our ninth standard chemistry parallel teacher, Ms. Urmisha, and then we'll post it on MCB, right? I hope you have got the syllabus for the evaluation 2. If you have any questions regarding chapter 2, right, uh, matter in our surroundings and right, the properties of matter, different uh, the different purification methods that you have studied over the time. I remember that ma'am had taken one actual demonstration class also, where she had explained very well how distillation and evaporation works, right? Yes,
Yes,
everyone.
sir.
Yes, sir.
That's
Yes.
better. That's better. Yes. So, if you have any questions, do let me know in time so that we can take up. Otherwise, we'll move further with our own chapter. Right. I'll be taking care of this in the next chapter. So, yeah, again, right, if you have any questions, do let me know.
No, sir.
Okay, that's better. That's fine for now. So that's pretty much it. Like I said, you have got some questions from the textbook itself. Always write those questions from the textbook in text questions, and I'll be sharing some more questions for you. I won't be giving answers directly, right? You will have to work it out, and you will have to find out whether they are true or not based among your own discussions, right? You can definitely take help from Google or any other website which you find useful, and I would recommend that you keep on reading some different resource materials, resource books. In this current scenario, you can find n number of books online, right? Almost every other book, every other reference book is available online. So go for it, download it, read as many books as you can, read as much as you can about structure of atom, right? Any questions so far?
No, sir.
None? That is amazing,
No, sir.
because I still have questions. I still have questions. You should be having questions, a lot many questions, right? Anyone else, apart from the regular questions that I've been asking, anyone else has done some research and want to ask me? Yes? No?
सर मैंने की है ना.
Sorry?
I have done about
Who?
Vedic science, Maitrasa.
Maitra Shah. Okay, Maitra. What you have read and what do you want to talk about Vedic sciences?
Sir, there was one chemical.
Hmm.
In that chemical we drop that chemical in ocean, whole ocean can dry up.
I didn't get it properly. Come again? Yes, Maitra. Come again, please.
मतलब एक ऐसा केमिकल था जो
Hmm.
हम ओशन में डालें ना तो पूरा
Hmm.
ओशन ड्राई अप हो जाता है.
Uh, well, that's I wouldn't say that's entirely not true, because there are super absorbents available. Yes, right. You must have seen those acrylic balls. They come up with tiny small plastic balls, and when you add them in water, or you add water in them, they absorb and they swell up, right? They swell up. Okay, they become larger and larger, and after after some time they start disintegrating. That is true, right? So there are super absorbents, but as far as going as far as absorbing that kind of volume, right? Because when it comes to oceans, the water is in some big numbers, right? We are talking about, and absorbing that kind of volume will become very difficult. Okay, right? And then containing that kind of water volume in a specific structure, that is going to be very difficult. So yes, uh, again, uh, in Vedic science there are many things which have been said, and I'm not refusing, but at the same time I wouldn't just buy anything from anyone, right? I will definitely look for more answers, that what were the preferred